All right, so identifying the center and radius of each circle. All right, in order to do that, what you have to do is you have to understand what the actual equation of a circle is. All right, the first thing I like to show kids is, or I like to try to remind them that the equation of a line in point slope form was y minus y1 is equal to m times x minus x1. All right. Now, the point that was on the graph was x1 comma y1. And notice what's inside the parentheses. Come on now, you really got to be listening now. All right. What's inside the parentheses and the actual value, those signs are what? Opposites of each other. All right, they're opposites of each other. All right. Now, that's the equation of a line. All right. So yesterday I wrote up on the board the equation of a circle written in center radius form, and then there's something called the standard form. I'm going to give you the form that you can look and see what the center and the radius of the circle is. So that would be x minus h squared plus y minus k squared equals r squared. All right. That's the form you need to be in so you can identify the center of the circle and the radius of the circle. All right. Now, h and k, for whatever reason, is the letter they chose for the center of the circle. All right. If you remember anything about the parabolas from last year, h and k was also the vertex of a parabola. So it's just standard. All right. Now, here, the center of the circle, all right, the center is h comma k, and the radius of the circle is what? Is equal to r. Notice in the formula it's r squared, and the radius is r. Notice the center is negative h and negative k, but when you pull it out of the equation, it's the opposite sign. All right, so relatively easy. All right, it's relatively easy if you understand this is the formula for the center of the circle. All right, and we say that's just given the center and the radius. All right, then there's a different format that you can't look at directly and say, well, that's the center and that's the radius. All right, and that form would be considered general form, which is ax squared plus by squared plus cx plus dy plus c equals 0. All right. That's called the general form. All right. Now notice in front of the x squared and the y squared, I made a mistake. So technically it shouldn't be a and b, but in the circle, the coefficients of the x squared and the y squared will always be the same. All right. It's an ellipse, believe it or not, if the numbers in front of the x squared and the y squared are different. All right, that's something you learn in Algebra 2 next year. All right, so again, this is called the general form. And this is kind of called the standard form. And the standard form just allows you to see exactly what the center of the circle is and what the radius is. All right, general form, you have to move from the general form to the standard form. All right, and that's what sometimes kids think of as a little challenging. All right, but it's not really. All right, so let's go back and see if I taught you anything. All right, so identify the center and radius of each circle. So we're just going to go down the page. I'm going to do the odds, and you can do evens for homework. All right, so who wants to tell me what the center of the circle is for number 1? Good job. 0, 0. That's how simple. Now, how do I know it's 0, 0? Because you could rewrite this as x minus 0 squared plus y minus 0 squared equals 7 squared. All right, but of course you don't have to do that. You just simply say, since there's nothing after the x and nothing after the y, then it's what? Center is 0, 0. So we would say the center here is 0, 0, and the radius, of course, is what? 7. Simple as that. Anybody have any questions? All right, if you know, like I said, if you know the standard form, it's very, very simple. Very simple. What?
So you just, it looks like the pattern.
Well, no, it's not. All right. The reason why
I know it's not, but it kind of.
No, but I'm saying the reason why I'm saying that is because for this, all right, the reason why I'm saying that is because we're actually talking about graphing. We're actually talking about graphing. So the x corresponds to the what? X-axis, and y corresponds to the what? To the y-axis. We're actually physically graphing. All right. And so the Pythagorean theorem, you're right, a squared plus b squared equals c squared. But in this particular case, we're talking specifically about graphing a circle. All right. And pretty soon, as we go down the page, you will see we'll start graphing. All right. Very simple. All right. Very simple. All right. Now, for number 3, then, you should be able to tell me that the center of the circle is what? Right. It's very simple. The center of the circle is -2, comma what? 3. And now you would just simply say the radius is, yeah, the square root of 183. And that's all you would do. What, Dalton? What do you want it to be? What? So, again, I'm asking you, if you pull up this equation, x minus h squared plus y minus k squared equals r squared. Watch what I'm trying to tell you. It's this easy. HK, I told you, was the center, didn't I? Mm-hmm. So now what I'm trying to get you to realize is look at this and look at this. What's true? They're opposite signs. You hear what I'm saying? Yeah. So that means if it's 2 here, that's all. That's all it is. And I tried to show you that's the same thing that happened when you did your point slope. When you plugged the point in, it was the opposite sign. All right? So here we go. Number 5. All right, so everybody should be able to quickly tell me that the center is? Yeah, look how easy. -10, -9. And of course now the radius is what? The radius is 6. I told you. Simple, simple, simple. All right. Now again, we can look at number 7 and say, obviously, center of the circle is, and the radius is 11. So obviously, that is very simple. Bless you. All right. So now, obviously, now for number 9, we have what? We have a big problem. All right. This is what I was saying, where if you don't practice, all right, it's going to be hard. You're not going to be able to learn this in a night. All right. Now, last year in algebra, we did something called completing the square. We just did it for a couple days. We had a little quiz on it or whatever. I wouldn't expect you to remember it. All right. But that's how we're going to convert this into the proper format. All right. So what I'm going to do is, I don't want to run out of room. So I'm going to copy this. I'm just going to put it down here. All right. And then I'll show you how simple it is to convert from one form to the other. All right. Now, the first thing I want to do is, all right, I want to put the x's together. All right. So the first thing I'm going to do is, I want everybody to put down x squared plus 26x. Then we leave a space. And then it's plus y squared plus 28y, leave a space, equals -364. Now, the first thing you have to do is look at that and go, what is he talking about? It's -1, it's not negative here. Does everybody understand what I did there? Do I have any questions? Come on. I know some of you do. You're just not asking. What?
I'm so.
So all I did was I put the x's together. So this negative 26x has to go with that x squared. So I just moved it over. So when I moved it over, it became a positive 26x.
Oh, so you just.
And then I grouped the y's together. All right, but I put the y squared first. Then the positive or the constant has to go on the other side of the equation because I don't need that, because that eventually is going to be your r squared. All right, that's going to be your r squared. All right. Now, do you remember how we completed the square last year? All right, so to complete the square, all right, the format is always b divided by 2 and square. All right. Now, think of it this way. This right here is part of a quadratic, and a quadratic just means something to the second power. So when you think of a quadratic, you're supposed to be thinking of ax squared plus bx plus c equals 0. That was the quadratic that we did last year. All right, for the quadratic formula. All right. So in this case, the b is simply the number in front of the x term. So what's in front of the x term? 26. So in order to complete the square, all right, you take half of 26 and then you square it. All right. Half of 26 is 13. 13 squared is 169. So we're adding 169. So I'm adding 169 to this part of the equation. If I add 169 to the left side, I'm probably going to have to do what? Add it to the right side. So over here now I'm going to add 169. All right, so that was completing the square for x. Now I have to complete the square for what? Y. All right, so to complete the square for y, I'm going to take 28 divided by 2 and square it. You should be able to tell me that's 196 plus 196 plus 196. All right, anybody have any questions with that? All right, and if I do negative 364 plus 169 plus 196, is that 1, I think? Is that right? 1? All right. Now what I want to do is I'm just going to rewrite this now just so I can show you something. X squared plus 26x plus 169 plus y squared plus 28y plus 196. Now, the reason why they call it completing the square is because that makes this trinomial a perfect square, and it makes this trinomial a perfect square. All right, what does that mean? 49 is a perfect square because 7 times 7 is 49. 36 is a perfect square because 6 times 6 is 36. This x squared plus 26x plus 169 is a perfect square because that is just x plus 13 squared. That's what that is. Now, how did I do that? Well, we completed the square by taking half and square the middle term. That's the value of that. Now, how do I know what it factors to? I always tell kids it always factors to whatever the half was. It always factors to whatever the half was. All right? So how would I factor the y squared? What would that come out to be? Yep, y plus 14 squared equals 1. I don't think that's that hard. You just have a couple steps you have to remember. To complete the square, you take half the middle term and square it. We call it b over 2 squared. Then once you complete the square, you got to make sure you remember to add it to the right side of the equation. Then after you complete the square, you always have to factor, and it always factors into whatever the half is. All right? Listen, you'll be light years ahead of most kids if you understand that. All right? Does everybody understand what I mean by x plus 13 squared is this right here, right? Right, if I square x plus 13 squared, if I multiply that out, that will give me x squared plus 26x plus 169. That is a perfect square. Yes. Well, I got the 1. Well, I could be wrong, so double check me. I thought I did the math. I added that up. Right, I added that up. All right. Now, here, you should be able to tell me then, what is now the center of the circle, guys? Negative 13, comma, negative 14, and R in this case is what? 1. It really is that simple. All right, it really is that simple. All right, super important though, guys. Well, super, super important, especially next year for Algebra 2. All right, yes.
Does the right side of the equation always have to be positive?
Does the right side? Yeah, because you can't have a negative radius, right? Correct? Radius cannot be negative. All right, so with that, all right, that was number 9, correct? So now let's take a look at number 11. All right, so does everybody see number 11? I have negative x squared, right? I don't want negative x squared, so I'm going to throw that to the what? Left side, right? It's already on the right side, so I'm going to throw it to the what? Left. So if I throw it to the left, it's going to be, now you got to pay attention now, make sure you're hearing me. X squared minus 6x is in the right spot. I leave a space. Plus y squared, then what? Negative 32y, leave a space, equals what? Negative 264, because I didn't move the negative 264. Go. What? You leave a space when you're trying to figure out how to complete the square. You with me? You group the x's, you group the y's. When you group the x's and group the y's, I don't know what number that has to go there yet. So I need a number to go there so I can complete the square. All right? So now, at this moment, I don't really feel it's necessary, if you understand what I'm saying, to put b over 2. I think you're smart enough to just tell me, what am I adding to both sides to make that a perfect square? 9. I'm adding 9. Let's go with that first. Anybody have any questions with why I'm adding 9? All right. Again, for those of you guys, you're just taking half of the middle term and squaring it. What?
Why are you adding 9? Like, I get the negative 16, so you take negative 3 over 2.
I take half of 6, and then I square it.
Oh, I did divided by 2.
Half of 6, and then square it.
Okay.
All right? So then you ended up with plus 9. You ended up with plus 9. All right? Now, once again, you're going to take half of negative 32, but really the negative doesn't matter. And then you square that, which is 256. So now I'm adding 256, adding 256. I'm not too happy because that looks like it's 1 again, right? Yeah, so that's just a coincidence. Not always the radius is going to be 1. All right? Now that we've done that, you have now created the perfect square. So now this becomes what? X minus 3 squared plus
minus 16
equals 1. All right, and so from that, we now can just say that the center of my circle is
3, 16.
3, 16, and that has a radius of what?
1.
It has a radius of 1. It has a radius of 1. That's not bad. All right, not bad. All right, you need to understand that, though. All right. All right. Now, it's just a matter of let's practice graphing, okay? So in order to practice graphing, we just say that my center is what here, guys? Negative 1, 2, and then my radius is what? Radius is 3, right? That's the most common mistake is kids just forget that it's r squared, all right? So it's really r squared equals 9, so r equals 3, okay? So now, simple way to graph, we go plot the point negative 1, 2. All right. Then we have a radius of 3. So you count up 3, down 3, right 3, and left 3. All right, and the beauty of Notability is it will draw a what? Circle. Yeah, it'll draw a square for you. Right. All right. Yes, it was.
I think it was.
Here we go. So there's my circle, and you're drawing a pretty good circle there. All right, so that represents the circle.
How do you,
So all you do you just make a circle, and then you're allowed to just keep your finger there, and it blows it up, shrinks it up or down. Now, the important thing, if you want to kind of be accurate, you try to make a circle around the center of your circle, around the center, right? Then you just blow it up. All right. To me, it's always easier to make a smaller circle and then blow it up. That's why I like to put the dots. All right. Come on. Anybody have any questions with that? All right. So let's carry on. Let's go down to here now. All right, so same principle. All I want you to do is I want you to tell me what's the center of this circle. So -1, -2, and this time the radius is what? 5. So here we go. -1, -2. Plot your point. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then there's all your points. And again, I like to try to draw a circle around the center, and then if you blow it up, it's kind of fits pretty close. And there you have it. Anybody have any issues? All right, so here we go again. All right, some more practice here on 17. Center of the circle is what? -3, -2 with a radius of 3. So -3, -2. That's not bad, right? All right, let's see if there's anything else. Okay, so why would the 18 be kind of annoying? Because you have to figure out kind of what the square root of 14 is, right? That decimal approximation for square root of 14. You can find that on the calculator if you want. All right. Now, then if you'll look for tomorrow, we're just going to continue on. All right. And then you'll be writing the equations from the graph, which I think is kind of easy. Then you'll have some points. Then they'll give you an area you have to write. It's really kind of simple. All right, but you have to remember the formula for area. You have to remember the formula for circumference. And then you just take that information, you just plug it into the equation of the circle. But again, guys, this is a big part of the SAT also. All right, a lot of questions in your SAT and ACT deal with equations of circles. That's why it's important for you to be able to translate from the standard form or general form to standard form. All right, does anybody have any questions? All right, I think that's a good place to end for me today. So what I want you to do is just go down, and it looks like you really just have to make sure you know how to do 10 and 12. I think that's the hard thing. All right, and then tomorrow we'll finish the next. All right. I think, is the answers at the bottom of the page here? Yeah. So just in case you're having an issue, the answers are there. All right. Yes. Well, that's for tomorrow.
I mean, like the graphs.
Oh, I'm sorry, I missed it. That's why I said you're going to have to estimate where the square root of 14 is. And you have to estimate where the square root of 14 is somewhere between 3 and 4, closer to 4. It's just an estimation. You with me? All right, guys. Good job for today. Please make sure you get it done. All right, this is really the only hard thing, I believe. All right. And then again, we'll finish it up tomorrow. No homework for the 3 days because we have service day on Friday, and then Monday and Tuesday I'll have the Chapter 9 review ready. All right. Test on Wednesday.